So here we are with video 10. Yep, I know, 10 videos already. And you may be wondering where we need to go from here. You have now built a basic rig and could happily animate this guy, so you have all the knowledge to go on and rig your own character. The problem is, this is exactly that, a basic rig. Don't get me wrong, working through these videos has given you the foundations to now build upon, but the rig does have its issues. If you look at the way the shoulder rotates, it seems fine around the Z and X axes, but when you rotate around the Y axis, it deforms badly. Ideally, it should twist around the upper arm, not the shoulder, and to help achieve this, we will be adding what's known as a roll joint. The same happens at the wrist, although it also needs some weights adjusting here too by the looks of things. Again, when we rotate around the y-axis, it doesn't twist in the right place. This also needs to rotate around the forearm. We can also see these issues with the leg too, especially around the thigh area. And it looks like we have some weights to fix too. But an extra roll joint here would help. Even with the ankle, we could add a roll joint to help it twist too. I know your ankle doesn't naturally twist in this way, but adding another roll joint gives the animator a bit more flexibility, especially if you're working on a rig for a cartoon character. Now before we dive in, I just wanted to mention that you can now download all the source files for each part of this Rigging in Maya series from my CubeBrush page. You can find the link in the description below, and I will be updating this constantly every time a new video is uploaded. While you're there, why don't you grab some of the other tutorials, models or rigs I have on offer? Most are free, but if you would like to help contribute to these videos, all donations are welcome. Alternatively, if you enjoy these videos and want to say thanks, why not just simply treat me to a coffee? All you need to do is head to the link on the screen and in the description below. Right, let's dive in. So, as mentioned previously, we ideally need to move the twist movement from the actual shoulder down to the bicep area. So start by duplicating the humerus joint and move it out of the hierarchy. Let's delete everything beneath it too. I'm also going to make this a bit bigger so we can see the new joints more clearly, and we will also rename this to add roll on the end. This is essentially going to be the new shoulder joint, so this will have the weighting applied to it instead of the original humerus joint. We now need another joint, so duplicate this and rename it to bicep_roll. Now you could just move this down the axis to where the middle of the upper arm is, but I prefer to be a bit more precise. Select the humerus and radius joints and then the new bicep roll joint and go to Constrain, Parent and open the options. Make sure Maintain Offset is disabled so the joint will move into the correct position and not stay where it is. If we click Apply now, you will notice that the axis is misaligned. This is because the new joint is trying to stay between the humerus and radius joints while also matching their orientations. Let's undo that and try again with Rotate disabled. That's better. The joint is now only using the position of the other joints, so it doesn't rotate to try and match the orientation of the radius joint. Just delete that constraint now because we don't need it anymore. And let's parent the bicep roll joint to the humerus roll joint. So now we have the roll joints in place and we can use this to deform the model instead. In fact, I'll also turn on rotational axes so you can see how these rotate as we add the controls. The idea is that the humerus roll joint will control the X and Z axes, so won't have any Y rotation. Instead, that will be offset to the bicep roll joint. So move those and parent them to the main humerus joint. This way they will follow as the current rig is animated. What we need now is a way to lock the Y rotation. So as the shoulder control is moved, the Y rotation on the humerus joint stays as it is. Create a locator and rename it to left humerus roll aim. We're going to use this as a way to lock the Y axis. Let's quickly use a parent constraint to move it into the same position as the humerus joint. Actually, we need the orientation too. I'll delete the constraint node and let's make it a bit smaller. I'm going to move the locator behind the arm too. What we need to do is make the z-axis, which is pointing forward, always look at the locator. So to achieve this, we'll use an aim constraint. Open the options and I'll just reset them too. Even though the z-axis is going to point to the locator, we still need the joint to rotate with the rest of the arm. So we are actually going to make the joint aim at the elbow, or radius joint. We know that the y-axis is pointing down the bone, so change aim vector to 1 in the second column, which represents y. We now need to tell the z-axis to follow the locator, so change world up type to object up and put the name of the aim locator into the world up object box. Currently the up vector is set to y2, but we want to control the z-axis. Looking at the joint though, the z-axis is pointing forward, yet the locator is behind, so set the third column to -1. Now select the radius joint first because this is what we are aiming at, then the humerus roll joint because this is the joint being controlled, and click Add. If you move the locator, you will see that even though the roll joint is aiming at the elbow, we can control the way it twists by moving the locator. Now you can see that as we rotate the shoulder control, we still have movement around the X and Z axes, but when we rotate around the Y axis, it doesn't move. So this is perfect. Even though this helps lock the Y rotation, there are poses where the rotation will just flip. Like here, as the arm moves forward, the joint flips, which isn't ideal. We can get around this by moving the locator. As you can see, it fixes the issue, but you don't want to be in a position where the animator has two controls to work with, so we need a way to make the locator move with the arm, but also stay behind it. Duplicate the roll joints and move them behind the arm. Also move them out of the hierarchy too. We don't want these to be part of the main skeleton structure. Just delete that redundant constraint node and let's rename these. Maybe add aim to the end. Oh wait, that name's already used. Okay, let's use follow instead. And do the same with the bicep joint. Now parent the aim locator to the new humerus follow joint, so it will move as the joint does. We now need the new joints to follow the main arm, but we don't want them to twist and raise the locator up. Go to Skeleton, create IK handle and open the options. I'll just move this over. What we need is a rotate plane solver. Build one between the two follow joints. Now as the IK handle moves, the joints follow and so does the locator. Let's rename the IK handle and then parent it to the elbow, radius joint. I'm also going to hold down V and snap it to the same place too. So now as the arm rotates, the IK handle moves with it, which in turn moves the follow joints and the locator. But we have another problem. The y-axis is no longer locked because the IK handle is also twisting and causing the locator to rise. Luckily, this can be easily fixed. Select the IK handle and set the pole vector attributes to 0, 0, 0. Now the y-axis is locked again. You can rotate the arm again, but it's much more stable. If we try and copy what we did previously, so raise the arm and rotate around the x-axis, you will see that it no longer flips. Yes, it does start to twist at extreme angles, but that's much better than a flip. In fact, what we could do is move the locator a bit further back and see if that reduces the effect. That does look a bit better, but you can play with the position of the locator to get better results depending on your rig. I would maybe even try moving it out too, so it's further down the arm towards the wrist. The main thing is we now have a more solid shoulder rotation with little or no rotation around the y-axis. So that's the shoulder setup, so let's now make the bicep joint twist. Don't worry, this is quite simple, as all we need to do is transfer the rotation from the main humerus joint down to the bicep roll joint. Open the node editor. Just move this up so you can actually see it. That's better. So, I'm going to add the bicep roll joint first, and then the left humerus joint. This is the main skeleton joint, not the roll or the follow joint. Remember that the main humerus joint is still rotating around all the axes. We only locked the roll joint. What we can do is simply connect the Y rotation from the humerus joint to the bicep roll joint. Now as we rotate the shoulder, or should I say twist it, the humerus roll joint is steady, but the bicep joint is now twisting. So we are getting all the correct rotations in the right places. The problem is the bicep is probably rotating too much. We ideally need a gradual blend from the shoulder down to the elbow. Again, this is easily fixed. As you have seen before in these videos, we can just use a multiply divide node. Not a mash node. There we go. I'm going to rename this to left arm roll multi because we can also use this node to help set up the wrist later on. Just open these up. I'm going to connect the rotate Y attribute from the humerus joint to input 1x. And then output x to the rotate Y attribute on the bicep joint. So this is acting as a go-between essentially. At the moment it looks the same because we haven't set the amount the rotation needs to be multiplied by. We can change the input 2x attribute and this will be multiplied by the main rotation value. So let's just halve it with a value of 0.5. Now we're getting a much more gradual rotation down the arm. I'll just turn off the rotational axes on these follow joints. We don't need to see them. So it looks like we have another issue. As we twist the arm, the bicep is rotating, but it seems to get slower the more we twist. Even though I discussed rotation orders in an earlier video, we never really set them up for this character as we were building him, so they are likely set to the default value of XYZ. Yep, XYZ. So what's happening is as the joints are rotating, each axis is affecting the other. So we are essentially not getting a true y-axis rotation value. The default value of XYZ would be fine if Z was pointing down the bone, because the Z-axis is independent according to that rotation order. What we need to do is change this to represent Y pointing down the bone instead. So we essentially need Y at the end of the rotation order. So let's change this to ZXY. We also need to update the humerus roll joint and the main humerus joint too, so they all match. If they don't match, you will end up with conflicting values, which may result in the limb flipping. Okay, that's fixed it. And as a future point and a future tip, when in doubt, if things are flipping, always check your rotation orders. Actually, I'm going to update the rest of the arm too, so they all match. There we go, we have the shoulder and biceps set up. Now let's look at the wrist before we rework the skin weights. With the wrist we need a slightly different setup, but it is a bit simpler. Duplicate the radius joint and delete everything beneath it, and rename it to left radius roll. Let's also duplicate that joint and rename it to left wrist roll. I'll just increase the size again so we can see them. And also make the rotational axes visible. So the wrist roll joint needs to be where the wrist is, so I'm just going to use a quick parent constraint to match its position. With the radius roll, we need it to be between the radius and the wrist. So just as we did with the bicep, use another parent constraint to constrain just the transforms so it sits between them. Also remember to delete the constraints when done. It looks like these are parented to the humerus joint, so change that, parenting them to the left radius joint instead, so they follow the elbow. So we now have a roll joint to control the forearm and a joint at the wrist, which, like the shoulder, will have the Y rotation locked. We are going to use another aim constraint to achieve this, and another aim locator to control it. Copy the humerus roll aim locator and move it out of the hierarchy. Rename it to left wrist roll aim. Let's parent constrain this to the wrist roll joint quickly to get the correct position and orientation. And delete that node. We will also move this back too. Now parent the locator to the main wrist joint so it moves with it. With the humerus roll joint, we set it to aim at the radius joint. We're going to do the same here. Open the aim constraint options. Set the world up object to be the wrist roll aim locator. Now select the radius joint and also the wrist roll joint. Looking at the wrist, the y-axis is pointing away from the radius joint, so we need to change the aim vector to -1 instead of 1. The up vector can stay the same. Now as we move the locator, the wrist roll joint follows. If you now adjust the wrist control, you will see that the wrist roll will only move when the wrist is twisted. So now to wire up the radius roll joint, and it's exactly the same as we did with the bicep joint. If you go back to the node editor, you should still have the same nodes you were using before. Add the wrist roll and radius roll joints. Let's open these up. Like I said before, we can use the same multiply divide node because it has 3 inputs and they are all independent. If we connect the rotate Y attributes directly, we get the movement we need, but like the bicep, it's too much. Connect rotate Y on the wrist roll joint to the input 1Y attribute on the multiply divide node. Now connect the output Y attribute to the rotate Y attribute on the radius roll joint. Let's also change the amount the rotation is multiplied by to 0.5 again to halve it. There we go, that works. We can now rotate the wrist and the forearm will twist no matter where the hand is. Obviously, you will be able to see it better when we update the skin weights. So those are the main roll joints added and wired up. As a final step, parent constraint the humerus follow joint to the shoulder joint. This way they will follow as the rest of the body moves. Just make sure maintain offset is enabled this time. There we go. So the roll systems are in. All we need to do now is make them drive the mesh. So let's do that next. Go to Skin, Edit Influences, Add Influence and open the options. With the default values, if you add an influence to a skin model, it will apply default weighting values, which does usually affect all your other weights, which isn't ideal, especially if you spend a long time working on them. Click the Lock Weights checkbox and leave the default weight slider at 0. This will add the joints to the skin cluster but not apply any weight values to them, so you can keep the exact weights you began with. Select the bicep roll, the humerus roll and the radius roll joints. We don't need the wrist roll joint to be weighted as that's only used for its rotation value. Add the model to the selection and click Apply. Next, go to Skin, Paint Skin Weights and open the options. You will see that we now have the new joints listed as influencers. Also, if you select them, they currently have no weight values applied, which is perfect. They are also currently locked, as you can see with the yellow padlocks, so start by unlocking them. Let's pose the shoulder so we can see the roll joints in action. The humerus roll joint is going to be the new main influence for the shoulder, so select that first. Let's use Add and reduce the opacity, so we can gradually build up the weights. As we start to add the weight, you can see the shoulder almost rolling back into the correct position. Let's now move down and work on the bicep roll. It looks quite extreme, but I prefer to just throw the weights on and then soften them later. Because the humerus roll now controls the shoulder, we no longer need the base humerus joint to influence the model. Actually, let's switch the operation to replace and just flood the model to quickly remove the weights. We can now go back to the humerus roll joint and use smooth to see if we can soften this area. And the back too. Let's do the same with the bicep roll. I think we need to bend the elbow too, so we can work on the crease and the outer elbow, because the bicep joint needs to influence those. Yeah, because we removed the humerus influence, the weights have shifted, so this needs fixing. Just go through and add some more influence here. And on the outer elbow. Now I'm just doing this quickly for now. To be honest, I will probably come back and refine all the weights later with NG skin tools. I'm really not a big fan of Mayer's default built-in skinning tools. So that's looking better. Let's smooth this area now. And under here. So I might actually speed up the video a bit here. If you want to see a more in-depth tutorial on painting weights, check out the previous video in this series. Okay, so there you can see the twist in action. We have no rotation on the shoulder, instead it's being passed to the bicep area. Just hide the joints for now. It needs more work, but you're getting the general idea. As you can see, even with this quick once-over, it's deforming in a much more natural way. So let's reset these. And bring back the joints. Okay, onto the wrist. Always pose the area you're working on first. Just going to block in the forearm area, right down to the wrist. Soften this now. We have some stray weights up here. Just get rid of those. Switch to the radius joint. So let's remove these down here. This needs to be influenced by the wrist or the roll joint, not the radius. Let's see if we can smooth these out. More stray weights. Mayer's weight painting tools aren't the best. It seems when you use smooth, it just picks random vertices. There's just something about this area that doesn't look right. Let's try posing the hand. Okay, so the wrist is influencing the arm. That's probably the issue. Actually, it looks okay. No stray weights from the wrist. But knowing Mayer, it could be from something like the fingertips. Let's just check through the fingers. Ah, there we go, the end of the thumb. Why, oh why? So let's clean those up. Look at that, there's also an influence on the elbow. Okay, let's check the other fingers. The ring looks okay. Okay, some more on the pinky. Right, I think we're good. Let's look at the wrist now. Let's give that a try. Yeah, looking good so far, although we have an influence on the stomach area. Just hide the joints. Yep, the forearm is twisting nicely now. Again, this is just a quick once over of the weights. I would make sure you spend more time on them. Let's try posing the whole arm. Forearm looks good, a lot more natural. Bicep looks good too. Let's just reset these and bring back the joints too. It's probably a good idea to clean up the hierarchy too. I'll just move the humerus follow joint into the left arm group and hide the locators. So there we have the left arm done, complete with roll joints. Even though we've applied these to the left arm, you can use exactly the same process for the leg. Just treat the thigh like a shoulder and the ankle like a wrist. What I'm going to do now is I'm going to work through the rest of the model to get all the roll joints in and working. But there are a few things to keep in mind as you work on the legs. When working on the aim constraint for the ankle, you don't want the z-axis to shift so it points to the knee, because this will break the ankle. So in this instance, have maintain offset enabled. Just stay aware of the orientation so you set them up with the correct axis pointing the right way. Also, with the radius roll, we just focused on the rotate Y attributes when connecting them to the multiply divide node. With the ankle, you will need to connect rotate Z instead. And finally, if you find that the twist is reversed, just invert the value in the multiply divide node, so set it to minus 0.5 instead of 0.5. So there we go, all set up with both arms and legs. As you can see, the way the thigh deforms is much better with a nice gradual twist down to the knee, making it look a lot more natural. There's no extra attributes for the animator to worry about or edit, they work quietly in the background. Like I said earlier, the ankle doesn't twist like this, not naturally anyway, but it's good to have the option for more flexible characters. We have a nice twist down the forearm, There's an issue here, and this is what happens if you don't set the rotation orders. Once the wrist gets to a certain point, it starts to reverse, so I need to go in and just make sure those are set. Here you can see the joints. For the thighs, I just move them to either side and then parent constrain them to the cog joint. So there we go, roll joints done. I think while we're working on the limbs, we might look into making them even more flexible with some squash and stretch. And that's probably what we'll do in the next video. And then after that, we'll start to investigate creating a facial rig. So I hope you've enjoyed this video. If you have, please let me know in the comments below. Also, let me know if you have any questions, and also tell me what future videos you would like to see. Remember to download the files from my CubeBrush page, and why not say thanks with a small donation via my Ko-fi page. As always, remember to like this tutorial and subscribe to my channel to keep up to date with future videos. This is AntCGI signing off, and I will see you on the next one.